Hello, algebra students, and we are going on to Chapter 7, Section 3, the first day of 2, in finding out the third and final method that we have for solving our linear systems of equation, and that is by linear combination, or as we call it sometimes, elimination. We'll get to that a little bit later. So we're going to be solving systems by combination today. So how we solve a linear system by using the linear combinations method is, first of all, we have to make sure that the equations have their like terms in columns. That's very important so that we are able to eliminate one or the other of the variables. Then we have to multiply one or both of the equations by a number to get the coefficients that are opposites for one of the variables. Today, we're going to concentrate just on multiplying one of the equations by a number, and tomorrow, in the next lesson, we'll multiply both of the equations by a number. So then once everything is in the same columns and we do the multiplication, then we can add the equations together. And by doing this, we combine the like terms, and they will eliminate the one variable. So then we solve for the remaining variable. Once we do that, then we substitute that value that we just got into either of the original equations again, just like before, and then we solve for the other variable, therefore getting the ordered pair solution that we are looking for. So solving the system of equations by linear combinations, and I had already mentioned that we call this method elimination because we're trying to eliminate one of the variables so that we can solve for the other one. So we're looking at this system, 4x plus 3y equals 16 and 2x minus 3y equals 8. And I'm trying to decide, first of all, do I want to get rid of my x's right away, both of my x terms, or do I want to get rid of both of my y terms? And I'm already noticing that everything is lined up in columns. My x terms are lined up in columns. My y terms are also lined up in columns, and my constants are lined up in columns. So I'm good to go there, and I don't have to worry about changing anything in these two equations. So just looking at my x terms, in order to eliminate these, I would have to eliminate my x terms. I would have to make one of these equations, one of these terms, the opposite of the other. If I choose to eliminate my y's, in this case, that is going to be easier because they are already opposites of each other. Positive 3y and negative 3y are opposites, and they will give me 0 if I add them together. So that's what I'm going to do. I'm deciding to eliminate my y terms for this system of equations. And so I'm looking at them as they're written, and I can just eliminate those. Those eliminate to 0. So then what have I got over here? I've got 4x plus 2x, and that gives me 6x. That eliminates to 0, and I have 16 plus 8, which gives me 24. So now I can easily solve for x by dividing both sides by 6, and I have x equals 4. So I know that I have my x value of my solution to this system of equations. And now that I know what x is, I can easily find what y is just by choosing one of the equations and substituting x equals 4, substituting 4 for x in that equation. Again, it does not matter which equation you choose, whichever one seems easier to you. So I think I'm going to go with the second equation, and I'm going to put 4 in for x. So 2 times 4 minus 3y equals 8. So now I can easily solve for y just by doing the math. 2 times 4 is 8, minus 3y equals 8. So in order to get my constants on the same side, I need to subtract 8 from both sides, which gives me negative 3y equals 0. So I can divide both sides by negative 3 to get the y by itself, and y equals 0, because 0 divided by anything is 0. So my y value for this system is 0. So there's my solution for 0 to the system of equations. So in this system of equations, x minus 4y equals 14, negative x plus 2y equals negative 5, I want to do the same thing. I want to look at both my x terms here and here. Here and here, and both of my y terms here and here, and decide which one of those sets of terms that I can easily eliminate. So I'm looking at my x's, and I already have opposites. I have a positive x and a negative x, and if I add them together, x minus x is 0, and that's what I want. So I can just eliminate my x terms right away. So then I have negative 4y plus 2y gives me a negative 2y, and 14 minus 5 gives me 9. So now I have to divide both sides by negative 2 to give me a y value of negative 9 halves. And so I'm going to make my little ordered pair here and put that negative 9 halves in for where the y value goes so that I know that it's there. So now I have to take that y value and substitute it in to one of these equations to get my x value. And I'm kind of, again, as I've said, it doesn't really matter which one you choose, but I'm kind of heading toward the second equation because I've got a 2 here and I might be able to eliminate some of the fraction headaches that we have sometimes. So I'm going to use the second equation. So I have negative x plus 2 times negative 9 halves equals negative 5. So I need to multiply that 2 times the negative 9 halves. So I have negative x, and that's going to be a minus 2 times negative 9 halves is going to be a negative 9 because these 2's will eliminate. And then equals negative 5. So now it's easy to solve for x, and I need to get my constants on the same side, so I'm going to add 9 to both sides, and I have negative x equals 4. As you know, we're not finished quite yet because we don't want negative x, we want x. So we have to divide both sides by negative 1 to get rid of this negative sign on the x, and that gives us x equals negative 4. So I'm going to put my negative 4 in the x place in our ordered pair, and our solution to this system of equations is negative 4, negative 9 halves. Let's try one more system of equations to solve. And looking at both of the equations, x plus 2y equals 5 and 3x minus 2y equals 7, I can immediately see that I've got my opposites already set up here at positive 2y and negative 2y. So right away, I can eliminate those to 0 and go ahead and add the rest of the equations together. So x plus 3x is 4x, and 5 plus 7 is 12. So I have 4x equals 12. We need to get the x by itself, so of course we need to divide both sides by 4, and we have x equals 3. So I'm going to put my 3 inside my ordered pair in the x place. And now that I know that x is 3, I can go back and substitute in either one of the equations to get my value for y. And I think I'll choose the top equation this time because it just kind of looks easier than the bottom equation. So it looks like less work. So I'm going to put that 3 in for x. So 3 plus 2y equals 5. I need my constants on the same side, so I'm going to subtract 3 from both sides. So I have 2y equals 2. That's easy to solve for y. Divide both sides by 2, and I have y equals 1. So my solution for this system of equations is 3, 1. Okay, so for this last problem, we're going to have you pause the video and work this problem on your own, and we want to see the work on your notes when you come into class tomorrow. If we don't see that, then we will take it as that you did not watch this video. So please show all of the steps just as I've been showing them to you, and write your solutions. Put a box around your solution in ordered pair form, and we'll check with you and show you the solution in just a minute. So go ahead and pause your video. So as you can see, the solution to our system of equations is 0, 0. And if you got that solution, you should be really happy about it. See you next time.